Hi everyone, welcome back. So in this video what we're going to do is build the main body of the can. It's a relatively straightforward process and it's pretty quick. Let's jump into it straight away. The first thing I want to do is import my can profile file. So what we'll do is go to the File menu and we'll go down to Import. Okay. So the first thing you'll see is that when we use import, it goes into the data folder inside our project folder. So TVC can is our project folder, and data is our import folder, basically. Now, because I'm importing my binary file, I've actually moved it into the scenes folder, so we're going to have to move over to there. So I'm going to click on my TVC can now. Obviously, I'm on a PC. What you'll need to do is navigate up one folder level, okay, and look for your scenes folder just here. So I'm going to open up that. Now, at the moment, it looks empty, and the reason for that is that currently the software is trying to import OBJ files. Now, an OBJ file is an object file, and it's pretty much one of the most common 3D files and one of the older 3D file types available. Pretty much you can import and export these out of most, if not all, 3D software packages. It's sort of like the generic 3D file type per se. At the moment, that's what it's trying to import. So what I'll need to do is change this and look for the file type that I save my files as. And that is going to be a Maya binary file just here, a .mb. So I need to change this to Maya binary. Now on a Mac it's a little bit different. You possibly might see all of the different file types. What you might need to do is still change this to a Maya binary, but obviously the interface won't look like this. You might find a drop down might be sort of up the top of the panel perhaps, but you should be able to work it out. It's pretty basic. Okay, so let's take a look at the file. So what we want to do is select can profile. The two files that I've supplied for you are can profile and can ring pull base. Okay, we'll be using this one later on, but for now, can profile and click open. There we go. So what you should be seeing now is this curve, and you'll recognize this curve being pretty much the same as the image that I created in Illustrator, which I showed you guys in the intro video. So basically, what I'd done to produce this file, in Illustrator I created the curve as I explained in the last video. I imported it into here using create Illustrator object, Adobe Illustrator object just here, and basically all I did was I just set the type to curves and pressed create. Now what that does is it imports this, but it positions it. It reads the picture file from Illustrator and takes the vector path, any vector paths, into consideration, but what it does is it positions it under the grid down here. So this object originally was sort of down here somewhere in the wrong spot. So what I've done is basically positioned it where it needs to be and saved it as a Maya binary file, and that's the file that you guys have just imported. That's this file that we're looking at. Okay. Now because we imported this, we didn't just open the file. This is actually an untitled file. Okay. We're not actually in the can profile file. What we've done is imported that into an empty file. All right. And that means when I save this, it's not going to save over the original curve file. All right. So that's going to exist sort of separately to the file that we're working inside. Now that's cool because if we mess something up catastrophically, or maybe this file gets corrupted, we've still got the original curve file that we can just re-import into a new file, and we can just basically start over from scratch. So it's sort of an emergency backup. Okay, so this is just a curve. To have a quick look at the curve structure, if I right click here and I select, let's select edit points, you get these little purple crosses everywhere. Now these are the anchor points that I created in Illustrator. So these are all the positions I clicked in Illustrator. Now technically I can move these around inside Maya. I can use the move tool and start messing around, but it wrecks the shape of the object, and obviously we don't want to do that. But you can see there that you can actually edit the shape of the curve in here once you've imported it. All right. We're not going to do that though because it'll mess the shape of our can up completely. All right. So how do we turn this into a can? Well, what we're going to do is use a tool called Revolve, and what that's going to do is take this curve, it's going to spin it around an axis, and as the curve spins, it basically drops a surface behind it. For those of you who have seen Tron, either the new one or the original one, if you think about the light cycles in that film, how they drop a ribbon of light behind them that forms a wall, it's sort of a little bit like that. If you imagine this curve is the cycle, as this moves around, it basically is going to drop a surface behind it. For those of you that don't know what Tron is and haven't seen those films, well, maybe check it out on like IMDb or something. You'll probably find some reference, and you'll kind of get the gist of what I'm talking about. Okay, so let's revolve this thing. What we want to do is basically pop up to this Surfaces tab. Now, normally we do all of our polygon modeling from the Polygons tab, but curves use the Surfaces tab, and we're going to create a surface object rather than a polygon object. And the tool that we want is this one just here called Revolve. So Revolve, select curves, isopalms, or trim edges. Okay. What we have is a curve selected. So make sure this is selected. Just drag a box across it like this. And then what you'll need to do is double click this Revolve button just here. And that will open up the options for Revolve. And pretty much what we want is what you already see here. Okay, we don't really need to change any of these settings. So what we want to do is we want to have our axis preset set to Y, and that's going to spin the object from sort of down the center of it, okay, rather than kind of flipping it over on its front or on its back. Okay, we want the surface degree set to cubic. We want the start sweep left at 0, the end sweeps left at 360. What this is going to do is basically spin the curve 360 degrees. If this is less than 360, we end up with basically what would look like a wedge cut out of the object. So imagine you cut like a piece of pizza out, or like a slice of cake, and remove it. Basically, if this is less than 360 degrees, you'll get a similar result on your can. If this is more than 360 degrees, it's basically going to start overlapping surfaces, because the curve will basically go around 360 degrees plus a little bit more, and we'll end up with parts of the object overlapping themselves, and that will cause modeling tools later on to not function properly. So it has to be 360 for those reasons. Use tolerance can be just left at none. Segments, we want segments set to 8. Technically you could go over, technically you could probably go under, but 8 is a really nice value for doing cylinders, whether they be polygon cylinders or surface cylinders like what we're doing here. Curve range, just leave it on complete. And output geometry, we're going to output to NURBS. Now technically we're going to be converting them to polygons. So yes, technically we could go to polygons here and actually basically create a polygon object directly. But what I want to do is show you a different way of doing the exact same thing, so that you can see how we can actually convert NURBS to polygons separately. Not all NURBS objects are actually created using this Revolve tool, and I just want to kind of show you the idea behind that. So for now I'm going to leave this at NURBS. So a NURBS surface is basically a non-uniform rational B-spline. I don't know what that means. You'd have to be a mathematician or possibly a physicist to understand exactly what that means. But basically a NURBS surface is a surface that's calculated across basically a skeleton of curves. So if you think of maybe a trampoline, think about the steel frame or the aluminium frame on a trampoline. Think of that as being this curve. Now the mat of the trampoline, which is stretched out inside the curve, that's kind of what the NURB surface is. It's sort of that rubbery kind of panel in the middle. All right. So that's sort of what it is. It's a calculated stretchy surface over a set of curves. All right, so I'm just going to leave this here and I'll hit Revolve. There we go. So you can see there we've pretty much got this wireframe of a can, like that. Now if I switch my viewport to Smooth Shade All, which is this little blue button here, or you can press 5 on the keyboard, that's another way of doing it. We can set the object up so that it's solid on the viewport and we can get a better look at it. So you can see here it's set up as 8 divisions or 8 segments, okay? And you'll notice that there's sort of a bit of a flickery blue broken line in here. That's the original curve. I can click on that and select it. You can see that there, that little green line. Okay. Now you'll notice that if I move this curve, now I don't want you to do this, but I'm just going to show you this. If I move this curve, you can see that it actually edits in real time the shape of the NURB surface. So this is the NURB surface, and you can see that it's basically being edited by repositioning that curve. Now if I change the shape of that curve by editing its points, like I did just before, it will actually change the shape of the can even more. So technically we can actually animate the we could actually animate the shape of this can changing. We're not going to do that, but you know, depending on the job you're doing, you can actually change the shape of NURB surfaces if they've been created from a curve. So these holes that are formed, essentially, the reason why I set the file up for you guys is so that we wouldn't end up with any holes at the top of the can or at the bottom of the can like this. So I'm just going to undo here so I can kind of close that back up again. So it's important when you're doing a revolve function like this that the ends of the curves have to be smack bang in the middle of where the revolve axis is. Okay, otherwise you end up with holes or overlaps. Okay, so what we're going to do here is we're going to convert this object into polygons so that we can use our polygon tools and we can apply a UV template for texturing and so on. So what we'll do is we'll select the can. Now I'm not selecting the curve, just the can. And I'm going to come up to Modify and down to Convert. And I'm going to select the first option, which is NURBs to polygons. I'm going to go into the options for that by clicking the little box here. There we go. So we've got Convert NURBs to polygons options, and this is pretty much the same set of options that were available in the Revolve tool. Okay, the settings at the bottom of the Revolve panel are basically the same as these when we set it to polygons. Okay, so pretty much we want to have the settings set up like this. We want the type set to quads because I want 4-sided polygons, not triangles. Tessellation method we can set to general, and this will give us these options. Now the four changes you need to make are the first 4 options here: U type, number U, V type, and number V. U type and V type, you want to change the option to per span. So you've got 2 options here, 3 options here I should say. You've got per surface in 3D, per surface, and then you've got per span. Okay, what we want is per span, and that's for both of them. Now what that's going to do is basically, what it's doing is registering where it's going to place the divisions as being per, it's basically per panel is what that's referring to. So if we've got this panel here, another one here, a little one in here, and so on, it's the divisions that it's going to put in, the number U and the number V, it's going to be per each of these, rather than it being maybe across half the object or across the entire object. So the number U and the number V. The number U is basically how many divisions or how many polygons it's going to place across the horizontal width of any individual panel. The number V is the same thing but going vertically up the panel. So U is across and V is up and down on these panels. You can remember V because V is vertical. Alright. So in this case, I've set these to 4. So it's going to divide each of the panels on this object into 4 polygons. And it's going to do that to sort of round the shape out and try and keep it as close to this shape as possible. So what we do, once we've got those settings locked in, these can remain as they are. What we do is just press tessellate down here. Okay, the panel will disappear, and we end up with what you see here on the screen. So you can see it's kind of all glitching out. So what's happened is the original NURBS object is still there, the curve is still there, and it's created a new polygon object based on the NURBS object, and it's placed it directly on top of the NURBS object. So it's now sitting where the NURBS object is. So I just need to use the move tool and move it over to the side. So I'm going to grab that and shift it over here, like that. So this is the NURBS object, which you can see here. You can see those just rounded out NURBS panels. And this is the polygon object, made up of little polygons. Okay, and you can see here, essentially, if I select both of them, for each of these panels, there's approximately, or there is, 4 polygons. The easiest one to kind of see that with are these large vertical polygons here on the main body of the can. So for this panel, there's 4 polygons for that panel, and you can see them here. 1, 2, 3, 4. So it's 4 divisions basically. Okay. So essentially, that's our you could kind of say, well, that's the can 90% modelled. All we've got to do is model the ring pull, and pretty much the model is finished, which is true. What we want to do is just organise this scene a little bit. I don't need this, but I don't want to delete it. In case I mess up and I wreck something on this, I can just go back to this and reconvert it and end up with one of these and just fix the issue. Okay. Likewise, I'm going to keep the curve just in case I need to do another revolve. All right. So what we're going to do is just drag a little box that kind of cuts across the curve and the can, the NURBS can, I should say. And I'm going to place them in a layer, and I'm going to lock the layer off. So to get to our layers, we need to come across here to the Channel Box Layer Editor tab. Now, keep in mind that these tabs are visible because of the 3 icons in the top corner. These are all toggled on, and that's what gives us these tabs, which makes it easier to turn our panels on and off. So this is the channel box. Normally it's a lot narrower. It's usually about this wide. Okay, channel box at the top, layer editor at the bottom. What I'm going to do with these selected, I'm going to press the little button here. It has a little kind of star, a little blue sphere, and a little white floor panel. And it's called Create a New Layer and Assign Selected Objects. So all I do is click this, and it will place these objects into this layer. Okay. Now, in a second, I'm going to show you how I know that it's in there. But first of all, what I want to do is rename this. So I'm just going to double-click the layer on the name, and it'll pop the Edit Layer panel up. And I'm just going to type a new layer name in here. So I'm just going to call this NURBS in capitals curve, just like that. Now, unlike other panels in Maya, this particular Edit Layer panel, when you type in the name in, it doesn't like spaces. If you put a space in, usually if you try and press save, it gives you a warning. See, valid names only contain alphanumeric characters. You can't start the name with a digit, so it can't be one, NURBS curve, and white space characters are not allowed, like spaces. So what that means is if you want a space, you've got to put an underscore in, like that. Or what you do is you just you can just type all one word, and when that happens, the Maya convention normally is that the first letter of each word you do as a capital. And you can see that up here. So where it says revolved surface, it's all one word, but you can see that the word surface is separated out because it's got a capital S. And that's the way that Maya tends to do things. For me, I'm just going to leave it as this, just one word, and I'll press save. So I know that these objects are in this layer because over here in the channel box, we've got an input here that says NURBS curve, which is the name of our layer. All right, so that's the main way of identifying if an object is in a layer. There'll be an input, and it's usually the first input at the top with the layer name. Okay, regardless of whatever other inputs are in there, that one normally would be in there. Okay, so let's lock the layer. What we'll do is click this little box here in the middle. So we've got a V box, a little stroke box, and then this empty one. What I'm going to do is click it once, and it changes to T, and this goes into a wireframe. That's a template layer. So basically, it locks the layer. I can't select anything in there, but it goes see-through like this. All right, I'm going to click it again. So I click the T, and it switches to an R. Now what this is a reference layer. So once again, the layer's locked, but I can't do anything to the objects in the layer now. You can see it's still selected. If I deselect by clicking in an empty spot on the grid, and then I drag across again to try and select those objects, they won't select. So that layer is now locked. All right. Now the problem is obviously if I leave this visible like this, when I'm trying to work, this is going to get in the way. So what I want to do is hide this layer or switch the visibility off. To do that, I just press the V or click the V with the left mouse button, and it turns off. There we go. So I've got a locked layer storing my original NURBS object and the original curve, and I've got my polygon object. So I'm going to select the polygon object, and I'm going to change the translate X back to 0. Just type in 0 and hit enter on the keyboard, and basically my object will jump back to the starting point, which is the origin of the grid where it was created. There we go. So that's the main body of the can finished. Alright, so I'm going to leave this video here. We'll just save the file. So we'll go up to File, Save Scene, and you can see here it's going straight into the Scenes folder in my project folder. And I'm going to just call this TVC can and give it a number, 001. The next time I save the file, I'll save as 002. And that'll keep this file as it is, and it'll basically create a new file with a different number. Once again, that's so if the file I'm working on gets corrupted, I can go back to the previous file, so I don't have to start from scratch again. I don't have to start the project all the way from the beginning. I can just go back to the last file that I had saved. So we'll just press save there, save that. So you'll see up here, basically it's got the entire file path and then the file name. Now if you do something to this file, like you move something, or you do an extrusion, or you add a new material, you get a little asterisk just up here. Alright, and what that means is, if I just do this for a second, see this little asterisk appears. Okay, that means that something's been changed and your file hasn't been saved. As soon as you press save, the asterisk disappears again. Alright, so that's a little indicator whether or not you've saved your file or not. Okay, so with that said, I'm going to leave this video here. In the next video, what we're going to do is create the basic shape of our ring pull from the supplied file that I've given you guys. So there's lots of little things that we're going to be covering in the project. So we'll leave this one here, and we'll get stuck into the ring pull in the next video. So I'll see you then.